Hello, I'm Joseph Hill from the University of Amsterdam System and Network Engineering Group. Been doing some research on securing networks with P4. This is a part of that having to do with logging the path of flows. What that means and how we're going to go about it is what I'm going to tell you. So as traffic flows through a network, the traditional way of tracking a flow is with NetFlow, which at each node records where it came in, the source, destination, ports and addresses, and the port it's going out. And that's at each node. NetFlow can be CPU intensive, so one way of dealing with that is to do sampling. So instead of tracking every packet, you track 1 out of 100. For short-lived flows, this could result in only some of the nodes knowing about the traffic. And if you're trying to reconstruct the path afterwards, you may not be able to figure out exactly where it went through your network. So the idea is with security, if you later on determine traffic was malicious and you want to go back and see exactly how it went through your network, maybe so you can best place ACLs or such, you want the complete flow. And that's what we're going to attempt to do with P4. So a couple different methods. The first method, the most straightforward, is just as you move through the network, get an ID of every node and attach it to the packet. This isn't a new idea. It's in the IP protocol with source routing, and as mentioned earlier, in-band network telemetry does something similar to this. The issues with this is a variable amount of data is going to be added to each packet. This could ultimately affect your MTU that you allow, because you have to set MTU for the worst case scenario, the longest path. But this is the most straightforward. If you have a spine and a leaf network with short paths, but many different paths it could take, this may actually be a good fit. Second method is a bit of a special case scenario. So if you have OSPF running in your network, every node has a database that it could evaluate to know how every other node is going to route traffic. So as traffic enters your network, you could stamp it with the current routing database version and where it came to that network. As it moves through the network, you make sure that the database hasn't changed. And at the end, with the same flow data you would record with NetFlow, you record that routing database version number. Later on, if you find traffic and you want to know what path it takes, you look at that database version, compare it with an archive of router database information, and you can work out the exact path it took to your network. This is good if you have a network where you have OSPF, where you can reconstruct all your paths later on, but if you have routes coming from any of the routing protocols, that sort of breaks down. This could also have issues when you're using equal cost multipath routing, as it's not just the routing protocol to determine that. It could be round robin, that sort of thing. Good things about this is a fixed amount of data is added to each packet, though. The last method I'm looking at doing is inspired by MPLS. With MPLS, a label determines the path. With this technique, what path it takes determines the label applied to the packet. At each node, based on what it knows about the history of the packet, it'll give it a label. At the very least, it'll know what port it came in on. So that would be where it enters your network. Then at the next hop, it looks at the label that it already has, and the port it came in and gives it a new label. At the very end, this label is included with your flow data. Later on, you can work this backwards to find out the exact path it took through your network. This works well with routing changes. Even if there's loops in your network, this will still track that. It does keep state at every node, though. So if a node is rebooted or such, you would lose complete path information for that node. So just a couple examples, some of the tables you would see in a node just shows how the labels are changed and how the flow data would eventually be saved. One of the issues with this method is that the very first packet that comes in for a path would need to go to control plane, which could create delays. I'm looking at fixing that by doing some advanced, having the next label to use kept in a register so that the data plane would be able to access that without going to control plane. Still working on that though. There's some data saved on each node, but there is a fixed amount of information added to each packet. And yeah, this handles routing changes very well. As I said, it'll track the packet no matter where it goes in your network. So a few things I've learned so far working with P4. So far with P4.14, it's a little bit limited as far as getting access to hardware. Using the software switch currently, but even that doesn't implement all the features of the P4.14 language. Direct registers being one of the issues I've run into, which just aren't supported. P4.16's been released a few weeks ago. It's interesting to think about, so is development going to move towards P4.16, or are they going to keep working P4.14 to maybe include some of the features? And kind of have to look and see where that goes. Has some concerns about the portability of P4. It relies a lot on the target device. As far as packet replication, the pipelines, the architecture of the switch, every target could be different. And the last thing is the lack of a OpenFlow being tied to a protocol. There isn't a well-defined protocol-independent southbound plane so that your controller can talk to your data plane. Lastly, where we're going next, we're going to start doing some hardware testing with the Metronome SmartNIC. I have to evaluate whether I'll continue working with the P4.14 or P4.16. That's going to be completely based on what new features I get versus how good the support is. Ultimately, what I see as the future are designer protocols. So taking a look at what your network looks like in fixing a protocol or designing a protocol to fit your network. So instead of the small, medium, and large t-shirt, more like a tailored suit kind of thing. One of the things that's been hinted at with P4.16 is P4.16 uses individual control blocks. So in the future, it may be possible to change P4 code that's running on the fly. That's something I want to look at as even if you design a protocol now, you can have that protocol change as your network changes, hopefully. And I'm going to look at, can I mix P4 capable devices with non-P4 devices, which is certainly something that would be useful in implementing this. And lastly, just performance. As I add max action tables, how's that going to affect my performance, delays, and so forth? So that's the research I've been working on for about 5 weeks now, and that's where I'm going. Thank you.